Hi, we have the AP Physics 1 past paper 2018. We are discussing the section free response questions. In this part, we have the question number 3 which carry the 12 point. In this question, the disk shown above spin about the axle as its center, as shown in a figure. The student's experiment reveals that disk is spinning. The friction between the axle and the disk exert a constant torque on a disk. Okay. At time is equal to 0, disk has the initial counterclockwise positive angular velocity omega naught. The disk then comes to rest. From this point of view, we conclude that this torque is against the motion. Because why it come to rest? Because an external torque is acting, so it is opposing the motion. Okay. Question 1 A has a part 1. On a grid on the left, sketch the graph could represent the disk angular velocity as a function of time from t0 until the disk come to rest as t is equal to 1. So we have to sketch a graph for the angular velocity from t0 to t1 in which the body come to rest. And the B part on a grid below, sketch a disk angular acceleration as a function of time until the disk come to rest. Okay. So we have the situation. Now, according to this, we have the basic concept. There is a constant frictional torque acting on a body, which is against the motion. So torque is negative. So the angular velocity would be slowed down gradually at a constant rate. If you calculate the slope at any instant, it will be the constant, but its value is the negative because the initial velocity is higher and final velocity is 0. So the decrease in velocity is very smooth way in a constant way. And angular acceleration case, because the velocity is decreasing, the decrease in velocity, rate of change of velocity is called acceleration, but the velocity is decreasing, so acceleration is due to the decrease in velocity. So that is called deceleration. Deceleration is a negative acceleration and its value is always remains constant because the external torque is constant, mean the uh, value of the acceleration dependent upon the torque or external torque. If it is constant, then the acceleration is also constant, but its value is negative. Next part of the question, magnitude of frictional torque exerted on a disk T naught drives the equation for rotational inertia of the disk in terms of T naught, omega naught, and T1. As we come to know the equation, omega final, omega initial is equal to plus alpha t. As we come to know the final velocity, body come to rest, so it is 0. Initial velocity omega naught and the time is t1. Omega naught could be negative omega naught is equal to alpha t. We have alpha minus omega naught by t. And we have another equation for the torque. Tau is equal to I alpha, where I is the moment of inertia, rotational inertia, and the alpha is angular acceleration. For rotational inertia is equal to tau over alpha. We have the value of alpha, which can be placed in this position. So negative negative would be cancelled. T1 should be moved up. T naught over T1 is equal over omega naught. This is the rotational inertia expression in term of torque, angular velocity, and the time. Okay. In another experiment, disk again has the initial angular velocity omega naught at time is equal to 0. After time t half by t, the students start dripping oil on a contact surface between the axle and the disk to reduce the friction. As time passes, more and more oil reaches the contact surface, reducing the friction level. Okay. Now, again, it would be on the grid sketch the graph between represent the disk angular velocity as a function of time from t0 to t1, which is the time at which the disk came to rest in part A. Okay. And on the grid below, sketch the disk angular acceleration as a function of time from t0 to t1. So we have the situation now. We have the another axis point which is the half T1 on which the situation is changed. Now the oil is dripping, so friction will be decreased or external torque would be decreased. So let's see what happened. Point-wise point discussion. From 0 to t by constant frictional torque is acting. So torque is negative. This slow down evenly. The slope is negative and constant in this era, in this period. So you can see that in this part, the decrease in velocity is uniform. So velocity is decreasing, but in so negative slope is there, but value of the slope is the constant. After time t half, the oil start dripping, frictional force decreasing, so magnitude of external torque decreasing. Angular acceleration become less negative over the time, mean the slope of omega versus t gram must be less steeper over the time. Mean there no external torque, less external torque acting opposing the motion, so there would be less decrease in the velocity. And so we can see now the slope is not smoothly going down. It is now less decreased, less steeper as compared to the previous case. At t is equal to t1, disk has not yet stopped. As we come to the question, the friction is smaller, so it stops at above omega angular naught, omega 0. It has the certain velocity at time t. In previous case, it is approaches to omega naught, omega 0 at this time, but this time is not approaches to 0. Okay. For the acceleration case, 0 to t half by 2, frictional torque is constant, acceleration is constant, but its value is negative because the rate of change of velocity is decreasing. So acceleration would be negative in this half. So graph is horizontal line as you came from this situation. This is a negative value, but it is a constant value. What happened after t by 2? Let's see. We come to know the acceleration increased towards 0 because the external torque is less, frictional decreases. So its torque would be decreases, mean less negative. It goes to 0. Negative acceleration become less negative. That's the best words. So you can see it is still negative, but it is approaches to 0. Okay. What happened at t is equal to t1? The curve is rising to the initial negative constant value towards the 0, negative but closer to the 0. It might asymptotically approach 0 if oil keep reducing friction. Okay, that's the answer. Uh, Now next part, the student is trying mathematically model tau, the torque exerted on the axle of the disk when the oil present at the time t greater than half by t1. The student write down the two equations, each of the include positive constant c1 and c2 with appropriate unit. Both equations are shown here. Tau is equal to c1 t minus half t1, where t is greater than half t1, or tau is equal to C2 over t plus half t1, where time is greater than half t1. Which equation mathematically model this experiment? Equation 1, equation 2 explain why the equation you selected plausible and why other is not plausible. Equation 2 is a better model because when time is increasing, overall denominator is increasing. The tau is inversely proportional to this relation. When overall the denominator increasing, tau will be decreased. So this matches the experiment. As the time passes, more oil reaches the surface, reducing the friction further. So magnitude of the torque should decrease over the time. So this equation is representing as the time is increasing, tau is decreasing. But equation 1 is not plausible because it contradict when time is increasing, torque is increasing. So, but it is contradiction with our observation. Oil is reducing the friction, meaning the torque should be decreasing over time. But in this case, torque is increasing. So that's the solution. If you have any query, kindly ask in the comments. If you like the content, kindly subscribe and share with your friends. Okay, take care.